Right, additional points will be these, and except the read-only memory, except the read-only memory, cache, registers, and main memory here are volatile. RAM stores, GRAM stores currently accessing programs and data. SRAM also stores currently processing data and instructions inside L1, L2, L3 caches and registers. SRAM is inside or attached to the processor. ROM stores firmware, the system software stored by the manufacturer. So these are the points. So this has many points, right? It's stored by the manufacturer. A system software that is called firmware, such as BIOS and boot strap loader. Okay, now you can copy this note, write down this quickly because it's a very important part. So this can be used to answer many questions. So this, like if you write down this and remember this, in the exam you will get minimum 5 marks, maximum up to 12 marks. If you remember this part, minimum 5 marks. Minimum you will get 5 marks. Maximum you will get 12, up to 12, 15 marks you can get maximum. Maximum non-limit actually can be 12 or 15, but minimum you will get 5 marks. So it's very important thing. Okay, so the next thing is, right now we know about the memories, volatile memories, non-volatile memories, and here's our question paper, right? That is bit second one also you can answer. So it's asking the volatile memory. The first one, you know the which is the fastest. Fastest is cache memory in the above. So registers are even more faster than cache memory, right? Registers are even more faster than cache memory. Okay, question number 3. Computer has evolved from early mainframes to relatively small, smart devices with high computing power used today. Which of the following inventions contributed to the reduce of physical size of computer? Netoli, what is your answer? This anyone can answer. Sidmi, what is your answer? Yes. Which of the following inventions contributed to reduce the physical size of the computer?
Second one.
Sorry?
Second one.
Second one. Yes, bus is basically where data travels. Bus are data paths. Bus are actually where the data traverse, data pass, or the data lines, signal lines. ICs, yes, integrated circuits, introducing integrated circuits has drastically reduced the size of computers or computing devices. It has drastically reduced, right? Because the ICs combine thousands of transistors, and transistor combine like several hundreds of vacuum tubes. So it was like a microprocessor. It was the foundation to the microprocessor. Therefore, it has drastically support registers. Just those are memory locations, right? Nothing to do with this physical size. Solid state memory, SSD. That is also yes. Okay. Computers has evolved from the early mainframe to relatively smart devices. Solid state memories are also yes, because hard disk size is high, CD-ROM size is high, and SSD. So SSDs are very smaller. So that has also affected. Vacuum tube, obviously not. So are we going to select 4 or 2? 2 or 4? 4 or 2. ICs, obviously, ICs also helped a lot. But when you consider, okay, this is right. So this is important question, because this is where we have to argue. So okay, so we don't know the answer. So we don't know the answer given in the answer strip, but we can see, right? We can go and see what is given. What is the given answer? And so where's the answer scheme? This is the marking scheme. This is for paper 2 or paper 1. Okay, let's go for the marking scheme. But even though answers are given, so we have a valid argument here. What is the valid argument? ICs also reduce size. SSDs also, solid state memories also, solid state devices also reduce the size. Smart devices smart device වැඩිපුර contribute करे SSDs. SSDs contributed high to the smart devices, moving mobile phones and all. So, but ICs were there because ICs like it was there in the beginning also. Muladit then smart device වලට විතරක් නෙවෙයි IC help to reduce size in generally in all the computers. But for smart device, especially SSDs help. So we have that valid argument. Okay, let's see what is given as the answer. Answer for question number 3 is 2 ICs. So that was my first answer. Yes, that is 2. For 3, answer is 2. That is correct. But you have a valid point where SSDs, solid state memories, contributed reducing the size of the device when it comes to the like smart devices. So there will be like some arguments. So you can clearly select this integrated circuits because it helped throughout the journey. At the last stage, SSDs helped. Right. Consider the following diagram. Some hardware components, connections on a computer system. You can see CPU, something inside CPU, memory controller, display unit, video controller, keyboard controller, and hard disk control. CPU එක ඇතුලේ මොකද්ද තියෙන්නේ? The hardware part within CPU indicated by A about diagram set registers has memory translation maps to current running process. When given an input virtual address, the current process, it output the relevant physical address. So virtual address to physical address and physical address to virtual address translation is done by what is the device? Okay, Gihan, Umesh, what is the answer for this? Question number 4. What is the answer for question number 4? Yes, it is memory management unit. Virtual address to physical address conversion and physical address to virtual address conversion is done by MMU. Memory management unit. ALU is responsible for arithmetic and logical activities, mathematical, comparison, addition, division, subtraction, multiplication, comparison like activities. Control unit sending control signals to each and every controlling components. That is control unit. Cache memory. Cache memory is basically contributing to keep the memory inside the processor, but that is not doing any conversion of addresses. MMU is yes. Page table is basically responsible. It's in the hard disk. It's responsible for converting pages to frames and frames to pages, which is related to paging and framing in operating system. Lesson we learned this. This is MMU. What is a virtual address? Right? Virtual address means like some addresses are given without referring, because memory address field is lengthier. Memory addresses digai. Right? Have you seen memory addresses in your computer? Okay, let me show one. So who's going to share the screen? Any volunteer? If someone can share the screen quickly, then I can show you those memory addresses. I can give you 5 minutes, sorry, 5 seconds. Okay, 5-second time is over. So you don't want to see it practically. Therefore, I'm shifting back to this. Memory addresses are there in the computer when you go to the processor. So when you go to the management unit and when you see, my computer management, when you right click on my computer and select manage for this PC, then select manage. So you'll see the management console. So something like this, a management console. There, if you see here, if you see device manager, and if you select some devices, especially in the under device management, you can select memory, and then you can see some, so not this one. When you go to device manager and select device, you can see the addresses reserved for the memory device. Go for the memory device and see. You can see the addresses reserved for those. Those are memory addresses, but memory addresses are lengthier. Therefore, short addresses are used. It's like shortcut. The shortcuts or the short addresses or the virtual addresses are given to the MMU, and then the actual physical address is formed. It's a short address, a short code, like a at the physical address, at the RAM address. So that is the process. Okay, with that, we have answered 4 questions in the paper. Right, this anyone can answer because we have already discussed question number 5, 6, 7, and 8. Yes, we have already discussed this lesson, number systems and character representation. We have already discussed. I said that time also I said this will carry at least 5 marks. Number systems, character representations, that will at least give you 5 marks. So here you can see some marks. And in addition to that, in second paper and the structured paper also, you'll get some marks. Okay, so who's going to get all the marks? So please answer the questions quickly. Please answer the questions. 5, 6, 7, and 8. 5, 6, 7, and 8. I'll give you again 4 minutes. 4 minutes enough. Right, question number 5. Question number 5, consider 2 binary numbers, P and Q. If X equal P or Q and Y equal P and Q, they're asking about what? Bitwise operators. P and Q, not bitwise, not even bitwise operators. It's asking about the logic gates, logic connectivity of these bits. Right, you are having P and Q. So let's write P and Q. Okay. Right. P is 1011 0001 1011 0001, and Q is 0 1 0 0 triple 1 0 0 1 0 0 triple 1 0. Okay, you have to O this. So what is the speciality of OR gate? Without looking at this, can you tell me what is the speciality of OR gate? Yes. What is the speciality of OR gate? මතක නැහැ? OR gate එකේ විශේෂත්වය මොකක්ද පුතේ? මම ගොඩ සැරයක් කියලා තියෙනවා. Sidmi? Yes. What is the speciality of OR gate?
If one input become 1, the output will become 1.
If at least one input is 1, the output is 1. But there's a better way of telling that. If all inputs are 0, then only output is 0, right? So that is the better way of telling that, right? If all inputs are 0, output is 0. If එකක් හරි එක නම් එක තමයි. හැබැයි හරි විදිය මතක තියාගන්න, if all inputs are 0, then output is 0. If all inputs are 0, then the output is 0. That is the OR gate. Right, okay, let's consider the OR gate first. OR gate එක consider කරන්න. Here, all input 0 වෙනවද බලන්න. Here, මේකේ බලන්න ඕන අනුයාත bit හරි. Adjacent bits. So that respective bits. All are not 0, right? Therefore not 0. මේ දෙකත් නැහැ. 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 Nothing is 0. So all inputs are not 0. So all are 1, right? Okay, AND gate. What is the speciality of AND gates with me? Same thing. Can you repeat? What is the speciality of AND gate? AND gate එකේ speciality එක මොකක්ද? Sidmi?
If all inputs are 1, the output is 1.
Yes, if all inputs are 1, output is 1. If all inputs are 1, then output is 1. So if you don't know, my recommendation is please write down this because they are very important. If all are 1, output is 1. All are 1 කියන දෙකම එක වෙන්න ඕන. මේ respective numbers දෙකම එක වෙන්න ඕන. No, 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 no in this case, no in this case, no, nothing. So completely reverse. So it's zeros, all zeros. Because 1 and 0, no. 0 and 1, no. 0 and 1, no. 0 and 1, no. 1 and 0, no. 1 and 0, no. No. Because it need 1 and 1, 1 and 1, then only it's 1. Therefore, you are getting all zeros and all ones and all zeros. All ones, all zeros. The answer is here. X and Y respectively. X is O answer. O means everything 1. Y is an answer. And is everything 0. So answer is number 4. Okay. So if you do you have any doubts about that? Those who need, you can write down this. How the calculation happens. And if anyone needs, you can take a screenshot of this, or I'll send you the note also, right? I'll send you the note also. Okay. So important points, if all inputs are 0, OR gate will return 0. AND gate, if all inputs are 1, AND gate will return 1. Those are the important points here. Right, let's revert back. What is the 2's complement of decimal number minus 12? How to find 2's complement? Who's going to tell that? Satira, can you remember the 2's complement? Shimla. So what is 2's complement? How to find the 2's complement number?
First, we should find the 12's binary.
Yeah.
And then we should change into 8 bits.
Yeah.
Change it into 1's complement and add 1.
Yeah.
1's to
Yes, you have to find the 1's complement. 1's complement means the reverse. Right? First, convert 12 to binary. Exactly correct steps. Very good. Can remember it. So first of all, what you have to do? First of all, so there are actually 3 methods of representing numbers. The first method is called sign and magnitude. In sign and magnitude method of representing number, just changing the sign and keeping the magnitude as it is. That means plus 10 is 0 for the sign and 10 is 1010 once converted. But minus 10, you change only this, right? So plus right. So if it is a positive number, for positive number, all 3 methods are same. For the positive numbers, all 3 methods are same. Right? You're asking the fourth question. Fourth question is like, okay, I'll explain it. Yeah, fourth question I'll explain again, right? So don't worry, I'll explain again. So not now, there's another question. With that, I'll explain that part, right? Or you can just watch the video if in case like, because otherwise it will take more time, right? Anyway, I'll explain this, don't worry. So we will be discussing a lot of papers because we have enough time. In that, we will be discussing that. For positive numbers, all 3 methods are same. So sign bit is 0, and then the other bits in binary with beginning with actually leading zeros, or the fill in zeros for padding and making it 8-bit, 16-bit, etc. Okay, so all positive numbers, all 3 methods are same. Then Dana 10 නම් 10 කියන එක first you have to convert that to binary 10, so you have to divide by 2, then it is 5 remainder 0, 5 divided by 2 it is 2 remainder 1, 2 divided by 2 that is 1 remainder 0. 10 දෙකෙන් බෙදුවම 5 ඉතිරි 0යි, 5 දෙකෙන් බෙදුවම 2 ඉතිරි 1යි, 2 දෙකෙන් බෙදුවම 1 ඉතිරි 0යි. So 1 0 1 0. 10 කියන්නේ 1 0 1 0. ඒ 1 0 1 0 that 1 0 1 0, you keep it here. Zeros for padding, actually zeros for padding, I'm going to represent this green color. That is actually added here to make it 8-bit. Bit attack කරන්න තමයි ඒ ටික දාගන්නේ. ඒ කියන්නේ sign bit එක දාලා sign bit එක 0 නේ. Sign bit is 0. After that you add the padding bits. එතකොට ඔක්කොම 1 2 3 4යි. Then 1 0 1 0. එතන 4යි. All together 8 bits. So the register number is given, right? Register size is given. It can be 8-bit, 16-bit, 32-bit. Likewise, in the exam, register size will be given. In sign and magnitude, for the minus values, for the minus value, sign is 1. For minus numbers, or for negative numbers, sign is 1. Right, sign is 1, and you keep the same magnitude or same value in sign and magnitude. Sign is different, but value is same. In ones complement, sign is same minus sign, but value you have to invert. Value එක invert කරන්න ඕනේ පැත්ත හරවන්න ඕනේ. Here 0001010 will become 111010 here. 0001010 will become 111010. Ones complement. In ones complement, you have to keep the same negative sign and invert the magnitude part. Then you will get the ones complement. And if you add 1 to ones complement, you will get the twos complement. So after finding the ones complement, if you add 1, you'll get the 2's complement. Okay, so as I said, register size can be 2, 68, 16, 32, 64. So in the question, it will be given. But I need to ask one more thing. How to convert 2's complement to sign and magnitude? Yes, how to convert 2's complement to sign and magnitude? So please answer that question. How to convert 2's complement to sign and magnitude? Yes, how do we convert? Sidney, can you answer? How to convert 2's complement to sign and magnitude? Sidney, can you answer? Hello? How to convert 2's complement to sign and magnitude? 2's complement is this now. How do we convert that to sign and magnitude? Back to this. If you get this number, this is negative 10. How do you convert that to this negative 10? One thing is you can subtract 1. So after subtracting 1, you will get 1, 1, 1, 1, 0, 1, 0, 1. Then invert. So then you'll get 1, 0, 0, 0, 1, 0, 1, 0. Invert the non-sign bits. So invert the non-sign bits. Other than the sign bit, everything you can insert. Invert. That is method 1. There's another method. Method 2. So computers use method 2. This is method 1. Method 1 is difficult because you have to subtract. But with method 2, you just have 1, 1, 1, 1, 0, 1, 1, 0. First you invert. After inverting, you will get 1, 0, 0, 0, 1, 0, 0, 1. Then add 1. Then you get 1, 0, 0, 0, 1, 0, 1, 0. So that is easier. Because sign and magnitude to 2's complement. Invert and add 1. Invert kara ekak ekatu kara. Sign and magnitude dekina. Invert kara ekak ekatu kara. Then you have the 2's complement. 2's complement, invert again, add 1. You have the sign and magnitude. Sign and magnitude, invert again, add 1. You'll get 2's complement. 2's complement, invert again, add 1. You'll get sign and magnitude. That is one good method of converting and deconverting. Okay, you can write down this part also. If you have anything unclear, any unclear points, you can ask. Monahari noterena deyak tiyenawa nan ahanna. Okay, somebody was asking question, right? Okay. Anything unclear, you can ask. Let me once you finish writing, right? Let me know once you finish writing.